Okay, we will solve the next exercise. The exercise tells us a pressure transducer measures a value of 300 pounds per square inches. Determine the value of the pressure in pascals. A pascal is 1 newton per square meter. So what we are managing here are pressure units. So it is important for us to understand that a pressure unit is equal to a force divided by an area. When we are talking about international system units, then we talk about Newton per square meter. And when we are talking about US customary units, we talk about force pounds divided by, could be square inches, or could be square feet. So now that I've made that clear, it is also important for us to understand that 1 newton is a force unit. So a force unit is given by the Newton's second law, and a force is equal to mass multiplied by an acceleration. So mass is given in the international system units by kilograms. This is just a prefix. Maybe I'll explain that later. And acceleration in international system units, it is equal to meters per square seconds. And when we talk about US customary units, the mass units are the slugs, and the acceleration units are feet per square seconds. So as I've said before, this is not a unit, this is a prefix. And it is important for us to understand that the units that we are managing here are the grams. There is a chart, I used it for the previous exercise. Maybe let me copy it. So in this chart you can find it as units, prefixes, and you can Google it and you'll find this chart. You can see that here you'll find the unit, and on the upper side of the chart you'll find deca, hecto, kilo, mega, giga, tera, peta, exa. This is the one until this is the last one that I've memorized, but there is still zeta, jota. And this is centi, milli, micro, nano, pico, femto, atto, and this is the last one that I've memorized, but there is still septo and jacto. I've memorized until this one and this one, although I've never used it because it is this is pretty big, so big, and an engineer maybe in his whole life, maybe he or her is not going to use that kind of amount of digits. But it is important for us to understand that this kind of prefixes exist. So memorizing this table is actually pretty easy. You just have to memorize the prefixes, and the values are the easiest part of the chart, because you'll find here that deca is equal to 10 elevated to the 1 power. Then we'll have 2, 3, and starting from this point you just have to add 3 by 3. So 6, 9, 12, 15, 18, 21, and 24. Maybe there is some more, but this chart doesn't bring them. And on the below part of the chart you'll find the same values but with a negative sign, so minus 1, minus 2, minus 3, and starting from that point you just have to add 3 by 3. 6, 9, 12, 15, 18, 21, and 24. Then this kilo means this kilo times 10 to the third power. It is usually used with grams because grams is a pretty small unit. So this kilo like multiplies it by 10 to the third power. Okay, now that I've made that clear, we can start our unit conversion exercise. So 300 force pounds divided by square inches. So as I've said before, these force pounds are equal to slug times feet divided by square seconds. But we still got here square inches, in which I can imagine that are divided by 1 because it's the same thing that just have square inches. And then I'm going to this law in which I multiply this one with this one and divided the result by the multiplication of these two. Then the result is slugs per feet multiplied by feet per square seconds multiplied by square inches. So I gotta change these kind of units, transform those into international system units, which is Pascal, which is Newton divided by square meters, which is kilograms per meter divided by square inches and divided by square meters. So that maybe sounded like a tongue twister, but you'll understand it along the exercise. So 300 slugs per feet multiplied by feet per square seconds multiplied by square inches. Then I'm gonna transform those slugs into kilograms. I'm gonna transform those feet into meters, and I'm gonna transform those inches into meters as well, but I don't know the equivalence between inches and meters. But what I do know is the equivalence between inches into feet, and then I'm going to transform those feet into meters. It is important for me to notice this square because right here these two last divisions are the ones that are going to transform those square inches into square meters. So I gotta use this square here in which I have square inches and transform those into square feet and transform the square feet into square meters. That's what I use that second power right there, because if I don't use it, I'll get a wrong result at the end of the equation. Then I already know, and this is because I've memorized it, that 1 slug is equal to 14.59 kilograms. Then 1 feet, I don't know the conversion, but I do know that 1 meter is equal to 3.281 feet. The same, no, not the same thing here, but 1 feet is equal to 12 inches, and right here it is the same thing, 3.281 feet. So I just gotta find the result on the calculator. So let me write it. 300 multiplied by 14.59 divided by 1, then multiplied by, which is the same thing, I don't know why divided by 1 divided by 3.281 multiplied by 12 to the second power and by 3.28 1 to the second power. I've not write this one because this one elevated to the second power, it is still 1, and 12 divided by 1, it is still 12. So this denominator doesn't change anything to the division. And the same thing with 3.281 divided by 1. I just write those because with this using this form, I'll know that I'm eliminating slugs with slugs, fits with fits, square inches with these square inches, and these square fits with these square fits. And I'll get the result in kilograms multiplied by meters divided by square seconds multiplied by square meters. So the result is this huge number, 206,000. Oh no, my mistakes. 2,067,974.928. This is a huge number, so I gotta use the scientific notation here, and the result is 2.0679. I always use just 4 significant digits after the comma, multiplied by 10 to the 6th power, kilograms, meters, square seconds, meters, square meters, because of this square. And I already know that this part is equal to a Newton, so this is equal to Newton per square meter. And finally, I can use the same chart that I've explained before, in which times 10 to the 6th power is equal to mega, as you can see here. And I could write that with this symbol, which is a M. Then the result is 2.0669 mega Newton per square meter. This is why we use these kind of prefixes, and that's how this exercise could be solved.